Okay, Assalamualaikum and good evening. My name is Hazman bin BADRUNSHAM. So I want to explain my article, which is a framework to support behavioral design pattern detection from software execution data. Introduction. As a common design practice, design patterns have been widely applied in the development of many software systems. The use of design patterns leads to the construction of well-structured, maintainability, and reusable software systems. And generally speaking, design patterns are a description of combination objects and classes that are customized to solve a general design problem in a particular context. The detection of implemented design The detection of implemented design pattern instances during reverse engineering can be useful for a better understanding of the design and architecture of the underlying software system. As a result, the detection of design patterns is a challenging problem that has received a lot of attention in software engineering domain. A design pattern can be seen as a tuple of software elements such as classes and methods, conforming to a set of constraints. Table 1, which is in the next slide. Table 1 summarizes some typical design pattern detection approaches for object-oriented software by considering the type of analysis. Example, static, dynamic, and combination of both. Artifacts that are required as inputs, the description of pattern instances, what rules are used to describe the pattern, tool support, and the extensibility. This is the table 1 summary of existing design pattern detection approaches. You can see referral analysis type required artifact pattern system instance tools and accessibility. So the first one, static analysis technique. Take the source code as input and only consider the structural connections among classes of the patterns. Therefore, the detected pattern instances based on static analysis only satisfy structural constraints. With the abundance of static analysis tools on the on the one hand and the growing availability of software execution data on the other hand, combination analysis techniques come into reach. The second one is combination analysis technique. Let's input the candidate design pattern instances that are detected by static analysis tools and software execution data, and check whether the detected candidate pattern instances conform to the behavioral constraints. Therefore, the identified pattern instances using combination techniques match both structural and behavioral constraints. And the last one is dynamic analysis techniques. Can detect this pattern instances directly from the software execution data by considering sequences of the method calls and interactions of the objects that are involved in the patterns. A general framework to detect design patterns from execution data. Design pattern specification. The first one, a design pattern specification precisely defines how a design pattern should be organized, which included the rule set that is involved in the design pattern, the definition of pattern instance, a set of structural constraints, the definition of pattern instance invocation, and a set of behavioral constraints. Note that the way invocations are identified is specific to each type of design pattern and independent of the number of runs included in the software execution data. This is the general overview of the framework. Okay, the first one, which is candidate pattern instance discovery. By taking the execution data as input, we need to discover a set of candidate pattern instances. Example, finding the values, classes, or method. Existing static pattern instances discovery approaches focus on structural analysis of classes, operations, and their interrelationship. Example, inheritance, relation, and dependency. By exploring the source code that play certain roles in the pattern instances. Some of the roles that are played by interfaces as detected from source code will be replaced by the implemented classes from the execution data. Phase 2. Behavioral constraint checking. The pattern instance discovery takes as input the execution data as written and return a set of candidate pattern instances by considering only the structural constraint of the pattern. Example, especially among classes and methods. So the discovered candidate pattern instances inevitably contain false positives, especially for behavioral design patterns. Instantiation of the framework. Given the well design pattern X, the framework is required to support its detection. To execute the framework, design pattern inspection of pattern X and software execution data like the behavior of such pattern of grade. To test the applicability, we institute the proposed methodology to discover the observer state and strategy patterns. Later explanation will understand slide. Observer design pattern and erroneous apart. Define the observer design pattern define one to many dependency between objects so that when one object that changes state, all its dependents are automatically notified. This is the structure of the observer design pattern. So we have the method, observers, the interface, and the observer. Okay, the observer is an interface that defines an ability interface for objects that should be notified of changes. Subject is a class that stores state of interest to observer object and send notifications to each interested object when its state changes. Notify is a method that is responsible for notifying the observers of the state change in the subject. Update is a method implemented by the observer objects can be called by the notify method. Register is a method responsible for adding observer objects to a subject object. And last one, and register is a method responsible for removing observer object from a subject object. Candidate observer pattern instance discovery. An observer pattern instance is an implementation of the observer pattern and it defines a binding from the row set to its value. Discovery process aims to find the missing value for all rows involved in the row set of observer pattern with respect to the structural constraints. As the algorithm discovers a set of candidate observer pattern instances using the structural constraints and the software execution data, it invariably produces some false positives. Variable constraint checking to check whether a discovered candidate observer pattern instance conforms to the behavior constraints. After obtaining candidate pattern instances and refactoring execution data by invocation identification, we can check whether a candidate conforms to the behavior constraint. A candidate observed pattern instance is valid if there exists at least one invocation that satisfies all behavior constraints. Otherwise, it is not valid. This is the candidate observed pattern instance discovery. As you can see, this is the screenshot of the DPAT. To implementation, the purpose of the detect behavior design pattern has been implemented as a plugin called Design Pattern Discovery from Execution Data DPAT in our From 6 package. All explanatory results in the following section are based on this tool. The detected observable patterns. This one is empirical evaluation. Subject software systems and execution data. Each system implements one or more design patterns. For each specific software system, we create its execution data by instrumenting different execution scenarios. As you can see, this is table 4, statistic of subject software execution data. So there is statistic until 1 to 6 and using real life. Quality metrics. Precision measures the percentage of the detected pattern instances that are correct pattern instances. Recall measures the percentage of correct pattern instances that have been correctly detected by our approach. Correct refers to the set of actual design pattern instances implemented in the software. Detected refers to the set of detected pattern instances based on our approach. The conclusion. As a dynamic analysis based design pattern detection approaches generally have problems in performing accurate behavioral constraint checking and providing an extensible mechanism to support novel design patterns. This paper proposes a general framework to support the detection of behavioral design patterns from software execution data. Okay, that's all. Thanks. Thank you.